Okay, so we want to find the exact area of this thing. All right, so we're going to revolve that about the x-axis. Okay, that's going to be a parabola, sideways one, and about in here, okay, where this is 3, this little vertex, and we're going to go to 6. Okay, so we want to find the surface area. So remember, we're looking at a little representative kind of rectangular thing here. Okay, and we're going to rotate that about the axis, right? So we're going to get this disk that runs around like so. Okay, so we're spinning this guy around and we get this disk. And again, if we unroll that, we're just going to have a big old rectangle. Now the edge of this rectangle is determined by the curve, so that's going to be the arc length. Okay, and this is the circumference. Okay, so remember that's 2 pi r. And then the arc length, we already know the formula for that. Remember, 1 plus f prime of x squared delta x. Okay, so I need to know the derivative, and just remember the radius then, that the radius of the circle is whatever the y-coordinate is here, because it's the height of that box and it ends there. So the radius, we will have 2 pi times f of x. So I need my function as in terms of x. So that's going to give me y equals square root of 4x minus 12. I'm going to go ahead and just play with this a little bit, because that's 4 times x minus 3, which would be 2 square root of x minus 3. I'm also going to need the derivative of that. So the derivative is going to be 1 over x minus 3, square root of x minus 3. You could think about that, if you want, as this. We take the 1/2 in front, so that gives me the 1. And then the derivative of the inside is just 1 when we multiply it. And just to make it easier when I start substituting things in, y prime squared is just going to be 1 over x minus 3. So now when I substitute all of that stuff in, the surface area is going to be the integral from 3 to 6 of 2 pi times 2 square root of x minus 3 times the square root of 1 minus 1 over x minus 3 dx. So let's see, I'm going to bring that 4 pi out front. The only reason I do that is I just like things in my integrand to be a little simpler looking. Sometimes it's good, sometimes it's not. Now I'm going to get a common denominator. Okay, so that's going to be x minus 3 over x minus 3. 3. That's supposed to be a 3. Okay. Now when I combine those, we're going to come across, that should be a plus. Okay, so that's a plus. X minus 2 over x minus 3. Now we'll notice we have the square root of x minus 3 here and the square root of x minus 3 here. So those two things are going to divide out. And we're going to be left with 4 pi integral from 3 to 6 of square root of x minus 2 dx. Now this is a good candidate for substitution. So I'm going to integrate this thing and I'm going to use substitution to do so. And we're going to let u equal x minus 2. So du would just equal dx. Now we need the new upper bound. So the upper bound is just going to be 6 minus 2, so that's 4. And then the lower bound is going to be 3 minus 2, so that's just going to be 1. So we're going to have 4 pi, integral from 1 to 4, of square root of u du. That's 4 pi. Now the antiderivative for the square root of u is 2/3 u to the 3/2. I'm going to evaluate that from 1 to 4. And what do we got here? So that's not writing. Okay. It does not like that page. So we're just going to go back up here and say, okay, well, that's, what, 4 pi. Now, if we do that at 4, that's 2/3 times 8. Square root of 4 is 2. 2 cubed is 8. Minus, then the 2/3 times 1 equals 4 pi. Now, I could factor out a 2/3, and that would be 2/3 times 7. So when I multiply that out, we get 56 pi over 3. And that would be our surface area. Hope this helps.